And so for this to be our system, right, slightly different than yesterday, because if I had straight down, nothing's going to cancel. The x's aren't going to cancel, the y's aren't going to cancel. That doesn't do me any good, okay? Because the whole point of elimination is to get one variable left. So what we have to do is we have to change one of these equations to make it so that it will eliminate. Okay, so in this case, I'm going to take this top equation and I'm going to multiply the entire top equation by 2. Because if I multiply that entire top equation by 2, and hopefully you can kind of see it, what's going to happen, those y's are now going to cancel out. So if I multiply that whole thing by, hold on one second here, I'm trying to get a different color, trying to get fancy here. So if I take that top one and I rewrite it after I multiply by 2, that's going to give me negative 20x plus 6y is equal to 2. Right? So I changed that. I multiplied everything by 2, every single term. Important that you're multiplying every single term by 2. So we've got these two as my system now. So now I can do what I did yesterday. Right? Add straight down. That's going to give me negative 25x. Those are going to cancel, is equal to 25. So now I can deal with a nice easy question like we did yesterday. Is just that one extra step. That's what we're looking at today. All right, that one extra step. And then, of course, once I get that -1 for x, I'm going to plug it back in. Go ahead and do that. Plug that back into one of the equations and solve for it. I would plug it into one of the original ones, one of the blue ones up there. Well, plug that back in. Make sure that you can get the right y value. I'll do that as well. So we plug that -1 in, and it shouldn't matter which equation you're plugging that into, whether it's the top or the bottom. Shouldn't matter. You're still going to get that -3 out for y, which gives us our answer of -1, -3. Again, we can still check that. We can still plug that back in and make sure that it works on both of them, right? We can guarantee that we have the right answer if we do that. So when we get to the quiz, we're going to want to do that. We're going to want to plug all these answers back into both of them. Make sure that it works. Don't just be satisfied that you got an answer. Make sure it's the right answer. Okay. All right, let's try another one here. As we're going, if you have questions, make sure that you are either chiming in or asking, right, in the chat. All right, let's look at x minus 3y is equal to 24, and 3x plus y equals 12. So here's our system. A couple different ways that we can go about solving it. But I want you to think, what can I do? What can I do to make these things eliminate? And this is kind of Cole's question. How do you know what to multiply by? You got to look at it. You're going to have to make something eliminate. Right? So whether it's the x's or the y's, doesn't matter. You need to make one of them eliminate. And so you're going to have to multiply one of your equations by something to get there. So let's hear from you. Which one would you multiply by, and what number would you multiply by? Either type it in or say it. Bottom by 3. Yeah, we can multiply the bottom by 3. If I multiply the bottom by 3, that means my y's are going to cancel, because then I'd have a positive 3y and a negative 3y. Okay, so I've got that. Is there another way that I could make these eliminate other than multiplying the bottom by 3? Yeah, the top by -3. If I multiply the top by -3, right? If I multiply the top by -3, then those x's are going to cancel. So it doesn't matter whether you're canceling out the x's or the y's, right? It's going to work. Eli's question, could you divide? We could, but dividing is more likely to get you fractions. And we don't want to deal with that. So if everything's divisible by that number, sure, go ahead and divide. But I'm not going to divide by 3 here and end up with fractions, okay? So we want to kind of stay away from that. So yeah, we can either multiply the bottom by 3 or the top by -3, and it doesn't matter which way you do it, okay? I want you to try one, okay? Try one of those. Either multiply the bottom by 3 and eliminate, or multiply the top by -3 and eliminate. All right, as you're finishing that up, I've got the work shown for either way here. So I multiply on the left side, I multiply the top by -3. And then you see the x's are going to cancel. I get 10y is equal to -60. Make sure, very important, like the most common mistake here, guys, is that we don't multiply every single term by 3. We have to multiply every single term by whatever we're multiplying by. A lot of times people will forget the right side of the equal sign. Okay, you got to multiply everything by that number to make it work. Okay, and we end up with 6 comma -6 as our answer. Remember, all of our answers are ordered pairs, and make sure you're putting them in the right order, x comma y. Always x comma y for that ordered pair. All right, good deal. Any questions on that so far? No? Okay, let's move on. All right, let's see. I'm trying to find a good one here. Here's a good one. Actually, we'll do this one first. Got 2 more for you here, and then a word problem, and then we're good. So we got x. No, that's not it. Let's try again. We're going to go x minus y is equal to -4, and x plus 3y is equal to a +4. So this one can be deceiving. A lot of times people think, all right, it's already set up. We can eliminate right away. But we can't eliminate because we have a positive x and a positive x. And if we're going to eliminate, one has to be negative, right? So what do we have to do to make this so that it will eliminate? Top by -1. Yeah, either the top by -1 or the bottom by -1, right? Either one. I would probably do the top by -1 because that's going to make those -y and the -4 positive, right? And we like positive numbers more than negative, but it doesn't matter. You can multiply either one by a negative. So when we do that, just make sure, let's say I'm multiplying the bottom because that's the first, actually, that's not the first one that we saw. Let's do the top. You could do the top by 3. Yeah, that's a good point. You could do the top by 3 and eliminate the y's. So there, as long as something's going to eliminate, it doesn't matter what you're multiplying or where, as long as something's going to end up eliminating. Yeah, that's a good point. But if I do that top one by a -1, that's going to give me -x plus y is equal to a +4. We're just changing the sign on everything, right? So now we add straight down. That's going to cancel. I get 4y is equal to 8. So I know y is 2, right? And we could keep going. We could plug it back in and get our answer. But I like what Ike said there. If I wish there was a better way than doing this. One thing at a time. Yeah, if I do the top by 3, right, that's going to work too. That's going to give me 3x minus 3y is equal to a -12. Now the y's are going to cancel. I've got 4x is equal to -8. X is going to end up being a -2. Right? So a lot of different ways. As long as something's going to eliminate, then we're okay. Right? Good. Any questions on that? Okay. Got another one here for you. This is going to be a trickier one. Let's go -2x minus 5y is equal to 9. And 3x plus 11y is equal to 4. So there's our system, right? And we need something to eliminate, either the x's or the y's. And we don't want decimals. We don't want fractions. Think about what we could do here. So Riley says, could we multiply the top and the bottom? Yes, absolutely, we can. And you can multiply them by different things. So you're going to have to change both equations here, right? Both equations. So think about what could I multiply the top by and the bottom by to make it so that something will eliminate, either x's or y's. Okay, if we do the top by 3, bottom by 2, yeah, we could do that. That would cancel out the x's, right? Could we multiply by something to cancel out the y's instead? The y's are a little trickier, right? But the general rule is if you want to cancel out one of your variables, just multiply it by what the other number is. So if you want to cancel out the y's, you're going to multiply the bottom by 5 and the top by 11. That's going to guarantee that you have 55s there to get rid of them. Now, those are going to deal with bigger numbers there, and we don't really, if we can help bigger numbers, right? If we want smaller, or if we can get smaller numbers, let's do that. So what I would do is exactly what we said for the first one. I'm going to take the top one, multiply by 3, and the bottom one, multiply by 2. Why don't you go ahead and try that one? Okay, multiply those, see what we get for an answer. All right, as you're finishing that up, the work is up here for you. You see it. I multiplied the top by 3, the bottom by 2. The arrows show where I went with the new, where I put that new equation. I kept them lined up, right? And again, we haven't mentioned it today, but everything needs to be lined up, right? Still just like yesterday. All the x's need to be on top of x's, y on y, equal on equal, constant on a constant. Everything's got to be lined up for elimination still to work. So I do that. My x's are going to cancel. I add straight down. I got 7y is equal to 35. Y gives me 5. I plug that back in. And again, I would use the original ones. It shouldn't matter, but the original ones have smaller numbers, right? So that's why I plug it into the original one. So I plug it into the original one. You see it on the right side, and I get negative 17. So we get negative 17 comma 5 for that answer. All right, any questions on that? All right, so we need to look at a word problem now. Okay, so I'm going to try to show the word problem up here while working on the iPad still. Let's see if we can do that. All right, hopefully we can see that. Oh, I can't move this, that's right. All right, so we can see that. We read it. If you can't read it, then I'll read it for you. It says a business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. Location B receives 2 large vans, 3 small vans for a total cost of $160,000. What's the cost of each type of van? So we've got two different company or two different locations here. So we've got location A and location B. So those are going to be our 2 equations that we're setting up. We're going to set up one for A and one for B. We have to determine what our X and our Y values are going to be. So we could write off to the side, X is going to be our large ones, Y is going to be our small ones. That way we know, once we're solving our equation, we know which one is which. So location A receives 5 large vans. So X is large, so 5 large and 2 small. And it was a total cost of $235,000. Okay, so that's our first equation. This is different than the word problems we had been looking at, right? The word problems that we had been looking at have been all, one equation is just how many total, and one deals with the money. Well, now it's different. Now we're dealing with one is location A, one is location B. And at the end, we're not finding how many vans or how many large or how many small like we were before, right? Those were the old problems. How many large candles, how many small candles? We know how many large and small vans we have. What we're talking about is what's the cost now? So this is a different question, right? They're asking what's the cost. So for the location A, you see it there, 5x plus 2y equals 235,000. And then for location B, it says we have 2 large vans, we have 3 small vans, and it was a total of 160,000. So once we do that, we have our system. Right? Now we have our system, and we're not going to solve this by graphing. Obviously, you don't want to graph 160,000. We're not going to solve it by substitution because we're going to end up with fractions and decimals. This is what elimination is for. Elimination is going to work every single time. I use elimination probably 95% of the time. just because I find it a whole lot easier than the other ones. Now, substitution still comes in handy when something is already solved for y or something is already solved for x, then we can plug that back in right away. That's the 5% that I'll use substitution. But this is great for elimination. So I want you to go ahead and I want you to solve this system. Okay, you're gonna have to multiply top and bottom by something. But I want you to solve this system, figure out how much each type of van costs here. Feel free to use a calculator. If you solve it different than me, that's completely okay. Let's see, at the beginning, how do we know what numbers, can't see my chat, to put X with and Y with? That's all going to be determined by your paragraph, right? By the question. So you need to determine which, if large is going to be X or small is going to be X, and it doesn't matter. But once you have that, then it says 5 large bands. So if X is going to represent my large bands, it's going to have to be 5X. And then small is Y, 2Y for that. I know it's kind of hard to see that paragraph, but. So you could eliminate either X's or Y's first, right? I decided to eliminate the X's. Notice that I multiplied one. One of them had to be a negative that I multiplied by, so that I have a positive 10x and a negative 10x. If you're going to eliminate Y's, that's great. You got to multiply the top by a 3, the bottom by a 2, but one of them has to be negative, right? One of them has to be negative. So if it was me, I would do the top by 3, the bottom by -2. I try to get my negatives on the bottom, but it doesn't matter as long as one of them's positive, one of them's negative. And then once I have that, Y, I solved for Y first. I got the X's to cancel. Once I get that Y, then just plug it back in and get your answer. So I'll finish this up while you're finishing yours up. I'll run out of room on the side here. So we're going to end up with 35,000 and 30,000. Now, in a word problem, we're not going to write it as an ordered pair for the word problem. The reason being is because, like I said, it doesn't say specifically that X is the large and Y is the small. We decided that. So when we get an answer, we're going to have to actually write out large van is 35,000. Small van is 30,000. I need to know which is which. Okay, and that's a common thing here, a common mistake on the quiz that's coming up. When you get those word problems, don't just write an ordered pair. Tell me what they are. So for my answer, right, I would say something about the large van being 35,000 and then the small van being 30,000, just so that we know for sure which one's which there. Okay, good. Any questions about our word problem here? This newer type of word problem? Okay. Take that as we're good.